reduction formula. It is rather the generalization from the nth integral to the n minus 1 or n minus 2. Like we will be having some integral in, which could be a definite integral or indefinite integral, and we will try to express it in terms of either in minus 1 or in minus 2 and so on. So that effectively if we could find out I0 or I1, then by back substitution we could be in a position to find out the value of nth integral as such. It is not nth integral, it is value of the integral for some n. That means we can find I5, I6, etc. The concept will be more clear if we take up a problem. Now the problem statement is to find the reduction formula for integral 0 to pi by 2 sin raised to nx dx. Let us call this as in. So we want to find a generalized formula. We want to find a generalized formula for evaluating integral 0 to pi by 2, say sin raised to 10x or sin raised to 8x or sin raised to 7x, and instead of independently deriving or using that particular formula, we will have a generalized formula for n, and then substituting n into it, we can find out integral 0 to pi by 2 sin raised to 10x dx or integral 0 to pi by 2 sin raised to 20x dx and so on. Now to evaluate this, we will have to proceed with, say, integration by parts, because as it is sin raised to nx we cannot integrate. So let us split that sin raised to nx as integral 0 to pi by 2 sin raised to n minus 1x into sin x dx. So there will be product of two terms, one of them should be differentiable and the other should be integrable. Of course every function can be differentiated, we are looking for the term which can be integrated, and here the term for integration is sin x. So treating sin raised to n minus 1x as function 1 and sin x as function 2, we will use the integration by parts formula, and integration by parts, the formula says that it is integral, this is the formula that we are going to use, it is integral function 1 into function 2 dx is equal to retain first into integrate second minus integral of differentiate first into integrate second, and this product is to be again integrated. This is formula for integration by parts, and this formula is to be used in this case. So treating sin x as function 1 and sin raised to n minus 1, rather sin raised to n minus 1x as function 1 and sin x as function 2, we will start with the formula. So it is retain first, that is sin raised to n minus 1x, integrate second, integration of sin x is minus cos x, and of course substitute the limits 0 to pi by 2, minus integral 0 to pi by 2, differentiate first, sin raised to n minus 1x will be differentiated as n minus 1 sin raised to n minus 2x into differentiation of sin x is cos x. So this will be the first term, differentiate first, and integration of sin x will be minus cos x dx. Now as we proceed with the substitution of the limits, at upper limit sin pi by 2 is 1 and cos pi by 2 is 0, so value at upper limit is 0. At lower limit sin 0 is 0 and cos 0 is 1, so at lower limit the value is again 0, so first term vanishes. And in the second integral, n minus 1 is constant that can be taken outside, and this minus sign will come out, it will be minus minus plus n minus 1 integral 0 to pi by 2 sin raised to n minus 2x, and cos x into cos x will be cos square x dx. This cos square x can be further written as 1 minus sin square x, so it will be integral 0 to pi by 2 sin raised to n minus 2x into 1 minus sin square x dx. Of course, n minus 1 constant is outside. We can split the integral, so it will be n minus 1 integral 0 to pi by 2 sin raised to n minus 2x dx, first term, minus n minus 1 integral 0 to pi by 2, it will be sin raised to nx dx. Now if we look at the given integral, then given integral is in is equal to integral 0 to pi by 2 sin raised to nx dx, and suppose we want to find in minus 2, it will be in minus 2 equal to integral 0 to pi by 2 sin raised to n minus 2 x dx. And so the term that we have calculated, which is representing in, left hand side was in, can be rewritten as in is equal to n minus 1, this is integral 0 to pi by 2 sin raised to n minus 2x dx will be in minus 2, and the second term will be minus n minus 1, it will be in. So collecting the terms of in on one side, we can write it as in plus n minus 1 in is equal to, it will be n minus 1 n minus 2, and so it will be 1 plus n minus 1 in is equal to n minus 1 n minus 2. This 1 cancels and n can be taken on the right hand side. It is in equal to n minus 1 upon n n minus 2. This will be actually the reduction formula. But now there will be different cases, like case 1, when n is odd, then it will be in is equal to n minus 1 upon n minus 2. As n is odd, n minus 2 is also odd. n minus 2 will be written as, start with 1 less, so n minus 3 upon the same term n minus 2. It will be n minus 4, etc. We will end with saying that I3 is equal to 2 by 3 I1, because this 3 gets reduced by 2, and then I1 will be equal to integral 0 to pi by 2. It will be sin raised to 1x, that is sin x dx, which can be evaluated. Integration of sin x is minus cos x between limits 0 to pi by 2. So it will be minus of at upper limit cos pi by 2 minus at lower limit cos 0. So it will be minus into bracket 0 minus 1 will be equal to plus 1. So we have got the reduction formula, which is in equal to n minus 1 upon n minus 2, and from that we are considering the first case when n is odd. We end up with saying that I1 comes out to be simply 1. Now this I1 should be substituted. This is what we call it as back substitution. And performing the back substitution, that is from I1 try to find out I3, using I3 find out I5, and so on, and finally we will get the formula for In. So we can write that I3 will be equal to, it was 2 by 3 I1 and I1 is 1, so it will be equal to 2 by 3. Similarly I5 was 4 by 5 I3 will be equal to 4 upon 5 into 2 upon 3, etc. When you proceed to find out In, it will be n minus 1 upon n into n minus 3 upon n minus 2 into etc. into 4 upon 5 into 2 upon 3. Ultimately In comes out to be, numerator is n minus 1 into n minus 3 etc. up to 4 into 2, divided by denominator is n into n minus 2, etc. up to 5 into 3 into 1. The formula for n equal to odd. N is odd. And for n even, that is case 2. When n is even, we will again proceed in the same manner. In will be n minus 1 upon n in minus 2, etc. We will come with saying that I2 will be equal to 1 upon 2 I0. And if we try to find out I0, it will be integral 0 to pi by 2 sin raised to 0x dx, which will be integral 0 to pi by 2 sin raised to 0 is 1 dx, and so integration comes out to be x, that is between limits 0 to pi by 2. Answer is pi by 2. With back substitution, we will get I2 to be equal to 1/2 into pi by 2. I4 will be equal to 3 by 4 into I2, that is 1/2 into pi by 2. Like that, if we continue, we will get In to be equal to n minus 1 into n minus 3, etc. up to 1 divided by n into n minus 2, etc. up to 2 into pi by 2 will be the formula when n is even. Will be the formula when n is even. And so combining the two results, combining the result of case 1 and case 2, comparatively we can say that, see the similarities, both the terms, numerator is starting with n minus 1, denominator is starting with n, and I am reducing n, the term in the numerator by 2, term in the denominator by 2. Dependent on whether they are even or odd, we will be either reaching 2 or reaching 1. Similarly here it is reaching 1 or 2, and this particular term is to be multiplied by pi by 2 dependent on whether n is even or not. And so the formula, the reduction formula for 0 to pi by 2 sin raised to nx can now be written as In is equal to, of course In is integral 0 to pi by 2 sin raised to nx dx will be equal to, start with one term less, so n minus 1 into n minus 3, etc. It could be either 2 or 1 divided by, start with the power n into n minus 2 into n minus 4, etc. up to 2 or 1. So if numerator ends with 1, denominator will end with 2. If numerator ends with 2, denominator will end with 1, and this is to be multiplied by pi by 2 if n is even. So multiply by pi by 2 if n is even. This will be the reduction formula for 0 to pi by 2 sin raised to nx dx. The formula by which we can evaluate several integrals when we proceed to our next chapters. Now on the same lines, actually we can find out the reduction formula for, if we are to find out the reduction formula for integral 0 to pi by 2 cos raised to nx dx, then remember that in definite integrals we have got a typical substitution or the principle by which we can proceed with simplification of this particular result. We have a result that integral 0 to a fx dx is same as integral 0 to a f of a minus x dx. Of course this can be very easily proved, because we can write a minus x is equal to t, therefore minus dx is equal to dt, or dx equal to minus dt. At x equal to 0, t comes out to be a, and at x equal to a, t t comes out to be 0. Therefore, the right hand side will be integral a to 0 f of t into minus dt. Minus sign can be taken outside, so it is minus integral a to 0 f of t dt. And then in case of definite integrals, the limits can be changed if there is a minus sign, so those can get inverted. It will be integral 0 to a ft dt. And also the variable is not that important because it will be taking up the values. I can substitute for t x and this will be fx dx. And so it comes out to be equal to LHS. Now this is the most important result which I will be using here, and I can say that In, which is integral 0 to pi by 2 cos raised to nx dx, can be written as integral 0 to pi by 2 cos raised to n pi by 2 minus x dx. But cos of pi by 2 minus x is sin x, so it will be integral 0 to pi by 2 sin raised to nx dx. And then we have already got the formula. It is n minus 1 into n minus 3 etc. up to 2 over 1 divided by n into n minus 2 etc. up to 2 over 1 into pi by 2 when n is even. And so the formula for 0 to pi by 2 cos raised to nx dx comes out to be the same one as we have written it for sin. First reduction formula was for the definite integral, and now let us go for one indefinite integral and find the reduction formula. It is to find the reduction formula for integral sin raised to mx into cos raised to nx dx. Now here the reduction is possible in terms of m or in terms of n. Let us go for reduction in terms of n in this case. So this can be written as I mn, and then to go for the reduction by n, we will try to reduce this n, because as it is sin raised to mx or cos raised to nx are non-integrable, and to go for integration by parts we will have to split one of the terms, and here I am going to split cos raised to n. So it will be sin raised to mx into cos raised to n minus 1x into cos x dx, where I will be treating sin raised to mx into cos raised to n minus 1x as function 1 and cos x as function 2. So using integration by parts, retain first, that is sin raised to mx into cos raised to n minus 1x into integrate second. Integration of cos x will be sin x minus integral differentiate first. This happens to be the product, so it will be m sin raised to m minus 1x into cos x. This is differentiation of u into v as it is, that is cos raised to n minus 1x, plus sin raised to mx as it is. Differentiation of cos raised to n minus 1x is n minus 1 cos raised to n minus 2x into differentiation of cos x is minus sin x. So this is integral differentiation of first into integration of second. Cos x will be integrated as sin x dx. So it can be now written as sin raised to m plus 1x cos raised to n minus 1x minus integral. The first term will be m. If you multiply by sin, it will be sin raised to mx, and if you multiply by this cos term, it will be cos raised to nx. That is the first term over here, and the second term will be minus n minus 1 sin raised to m plus 1x into cos raised to, this is going to be sin raised to m plus 2x, because there is already a sine term over here. There is already a sine term over here and one sine outside, so it will be sin raised to m plus 2 into cos raised to n minus 2x dx. So it can be now written as sin raised to m plus 1x into cos raised to n minus 1x minus, from the first term I can take m outside, it will be integral sin raised to mx into cos raised to nx dx, and then this is minus minus plus n minus 1 integral sin raised to m plus 2x into cos raised to n minus 2x dx. Now observe that this term is nothing but in, whereas here it can be written as, this is im comma n actually, whereas this is im plus 2 comma n minus 2, and remember that we are going for the reduction, and so we should not be increasing the value of m or n in this case. So let us go for separating out this sin raised to m plus 2x as sin raised to mx into sin square x, and then writing this sin square x as 1 minus cos square x, whereas in the next step I will be writing this as im comma n. So this will be sin raised to m plus 1x into cos raised to n minus 1x minus m comma n plus n minus 1 integral, it will be sin raised to mx into sin square x into cos raised to n minus 2x dx. Continuing ahead, first two terms are as they are, sin raised to m plus 1x into cos raised to n minus 1x minus mn plus n minus 1 integral sin raised to mx into 1 minus cos square x into cos raised to n minus 2x dx. We will go ahead, first two terms again as they are, and if we split the integral, it will be plus n minus 1 integral sin raised to mx into cos raised to n minus 2x dx minus, it will be n minus 1 integral sin raised to mx into cos raised to nx dx, which will be again im comma n. And so the simplified form can be written as im comma n is equal to sin raised to m plus 1x into cos raised to n minus 1x minus im comma n plus n minus 1 im comma n minus 2 minus n minus 1 im comma n. So taking all imn terms on one side, it will be im comma n into bracket 1 plus m plus n minus 1 equal to, it will be sin raised to m plus 1x into cos raised to n minus 1x plus n minus 1 im comma n minus 2, and then this one cancels, you can divide throughout by m plus n. It will be im comma n is equal to sin raised to m plus 1x into cos raised to n minus 1x upon m plus n plus n minus 1 upon m plus n im comma n minus 2 will be the required reduction formula. Here we have decided to reduce n. The same procedure can be applied if we decide to reduce m. In that case, initially sin raised to mx should be splitted up as sin raised to m minus 1x into sin x, and then sin x should be integrated, whereas sin raised to m minus 1x into cos raised to nx should be differentiated. So one of the important results. The next reduction formula that we want to find will be the same term over here. Only thing is, we will be given the limits of integration, which will be 0 to pi by 2. And to use those limits, it will be to find the reduction formula for 0 to pi by 2 sin raised to mx into cos raised to nx dx. In that case, I can use the result that I have got just now. So we can proceed to find the solution of this particular formula, the reduction formula that we are required to determine by the use of the previous formula that we have derived. We have Imn equal to sin raised to m plus 1x into cos raised to n minus 1x upon m plus n plus n minus 1 upon m plus n I m comma n minus 2. But when we substitute the limits, you will have to substitute the limits for the first term, and you will find that sin pi by 2 is 1, but cos pi by 2 is 0. So at upper limit the value of the first term is 0, and at lower limit sin 0 is 0. So first term will vanish, and we get the formula as I m comma n is n minus 1 upon m plus n I m comma n minus 2. This is a definite integral. Now using the same result, I can write I m comma n minus 2 as n minus 3 upon m plus n minus 2 I m comma n minus 4, and so on. Now it will all depend on whether n is even or odd. So let us consider the case number 1, when n is odd. If n is odd, we will be eventually reaching the term like I m comma 3, which can be written as 2 upon m plus 3 I m comma 1. It is just the substitution that I am having. N minus 2 is as good as 3, or you can use the original formula. N is 3, so this should be n minus 1, so 2, and this should be m plus n, so m plus 3. Reduce n by 2, so 3 becomes 1. And I m1 can be now written as integral 0 to pi by 2. It will be sin raised to mx into cos x dx, cos raised to 1x. Now this is integrable because sin x is equal to t will indicate cos x dx as dt. So this integration will come out to be sin raised to m plus 1x upon m plus 1 within limits 0 to pi by 2. At upper limit sin pi by 2 is 1, so this will be 1 upon m plus 1, and lower limit it is 0. So ultimately I m comma 1 comes out to be 1 upon m plus 1. And so we can back substitute it and find out Im3. So Im comma 3 in this case will come out to be 2 upon m plus 3 into 1 upon m plus 1. And if we go on substituting it, we will get Im comma n minus 2 equal to n minus 3 upon m plus n minus 2. Of course, the next term would have been n minus 5 upon m plus n minus 4, etc. up to 2 upon m plus 3 into 1 upon m plus 1. And so Im comma n will come out to be n minus 1 upon m plus n into n minus 3 upon m plus n minus 2 into n minus 5 upon m plus n minus 4 etc. into 2 upon m plus 3 into 1 upon m plus 1. So this can be written as n minus 1 into n minus 3 etc. up to 2 divided by m plus n into m plus n minus 2 etc. up to n plus 1. So this will be the result im, n when n is odd. The second case in this case will be when n is even. Case 2, when n is even. So we will end up with getting im4 will be equal to 3 upon m plus 4 im2. im2 will be equal to 1 upon m plus 2 into im0, and im0 will be integral 0 to pi by 2 sin raised to mx dx, and the reduction formula for the same we have already calculated as m minus 1 into m minus 3 etc. up to 2 or 1 divided by m into m minus 2 into m minus 4 etc. up to 2 or 1 into pi by 2 if m is even. So when we substitute it, when this particular result is to be substituted, we can write the result as two cases, because we are under the condition that m is even or m is odd, as the formula for im0 is indicating us. So back substitution will result in im2 to be equal to 1 upon m plus 2 into m minus 1 into m minus 3 up to 2 or 1 divided by m into m minus 2 etc. up to 2 or 1, and this is multiplied by pi by 2 if m is even, and we are under the case that n is odd. So going back, I can write im, n is equal to, it will be n minus 1 upon m plus n into n minus 3 upon m plus n minus 2 etc. into 3 upon m plus 4 into 1 upon m plus 2 into, it will be m minus 1 into m minus 3 up to 2 or 1 divided by m into m minus 2 up to 2 or 1, and this is to be multiplied by pi by 2 when m is even. So ultimately imn can be written as n minus 1 into n minus 3 etc. into 3 into 1 into m minus 1 into m minus 3 up to 2 or 1 divided by, it is m plus n into m plus n minus 2 etc. up to m plus 2 into m minus 2 up to 2 or 1 into pi by 2 if m is even. And this formula will be useful when n is even. So we have got two cases over here, dependent on whether n is odd or n is even. Now combining the results, I can rewrite the first formula for n odd as n minus 1 into n minus 3 up to 2 divided by m plus n into m plus n minus 2 up to m plus 1. If I multiply both sides, that is both numerator and denominator, by m minus 1 into m minus 3 etc. up to dependent on 2 or 1, whether it is even or odd, divided by the same term m minus 1 into m minus 3 etc. up to 2 or 1, then you will find that the denominator is continuously decreasing in terms of in steps of 2 every time. As we have got the case of the n even, it was m plus n that is continuously reducing by 2 till the end. We have got the denominator matching, even the numerator is matching, and these two results can now be written as a single formula, that is I m comma n, which is integral 0 to pi by 2 sin raised to mx into cos raised to nx dx. Numerator may start with 1 less for m, so m minus 1 into m minus 3 etc. up to 2 or 1 into n minus 1 into n minus 3 etc. up to 2 or 1 divided by, start with addition of powers m plus n into m plus n minus 2 etc. up to 2 or 1, and you will multiply this by pi by 2 when both m and n are even. One of the most important formula in the reduction, it is integral 0 to pi by 2 sin raised to mx into cos raised to nx dx is equal to m minus 1 into m minus 3 etc. up to 2 or 1 into n minus 1 into n minus 3 etc. up to 2 or 1 divided by m plus n into m plus n minus 2 etc. up to 2 or 1, and this overall result is to be multiplied by pi by 2 when both m and n are even. Now let us go for some application problems. Let us proceed with some application problems where we are going to use the results of integral 0 to pi by 2 sin raised to mx dx or the result of integral 0 to pi by 2 sin raised to mx into cos raised to nx dx. So those problems are, let us note down the problems. This is to prove that first one, integral 0 to pi by 2 sin square theta into cos raised to 6 theta d theta is equal to 5 pi upon 256. Second, integral 0 to pi sin square theta into bracket 1 plus cos theta bracket raised to 4 d theta is equal to 21 pi upon 16. Third, integral 4 to 6 sin raised to 6 pi x into cos raised to 4 2 pi x dx is equal to 21 upon 128. Fourth, integral 0 to pi x into sin raised to 5x into cos raised to 4x dx is equal to 8 pi upon 315. Fifth, integral 0 to pi x into cos raised to 6x dx is equal to 5 pi square upon 32. Sixth, integral 0 to 1 x raised to 6 into under root of 1 minus x square dx is equal to 5 pi upon 256. So we have got in all 6 problems over here, which are all based on the formulae that we have studied. The simple straightforward application of the 2 reduction formulae that we have just now calculated. Those formulae can be directly used unless you are required to prove them. If the question itself is to find the reduction formula for sin raised to mx or cos raised to nx dx, then and then only we will have to follow the procedure that we have studied up till now. Otherwise we can use the formula just by stating it. Like the first problem, it is integral 0 to pi by 2 sin square theta into cos raised to 6 theta d theta. It is sin raised to mx into cos raised to nx. Start with 1 power less 1 and reduce it by 2 up to 2 or 1. So we will stop at that point. Second power n is 6. N minus 1 is 5. So it is 5 into 3 into 1 divided by, start with addition, 2 plus 6 is 8. So it is 8 into 6 into 4 into 2. As both are even, multiply by pi by 2 and then simplify it is, and so the answer will be, numerator is 5 pi, this is 8 into 2 16, 16 into 4 is 64, 64 into 4 is 256, which is nothing but the RHS. In case of the second problem, which is integral 0 to pi sin square theta into 1 plus cos theta bracket raised to 4 d theta. Remember that the formula can be applied only when the limits are 0 to pi by 2. So you will have to reduce this theta to theta by 2. We have the formula for sin theta in terms of half angle. Sin theta will be written as 2 sin theta by 2 cos theta by 2. The whole square now, because it is sin square, and 1 plus cos theta can be written as 2 cos square theta by 2. So it will be 2 cos square theta by 2 bracket raised to 4 d theta. So effectively it comes out to be integral 0 to pi. This is 2 square, that is 4. This is 2 raised to 2 and this is 2 raised to 4. Ultimately 2 raised to 6 will go out. This is sin square theta by 2. Next term will be cos square theta by 2 and this is cos raised to 8 theta by 2. So ultimately it will be cos raised to 10 theta by 2 d theta. If we make a substitution that let theta by 2 is equal to t, that is theta equal to 2t, therefore d theta will be equal to 2 dt. And if we check the limits, theta equal to 0 implements that t is 0 and theta is equal to pi will implement that t is equal to pi by 2. We can write it this as 2 raised to 6 integral 0 to pi by 2 sin square t into cos raised to 10 t into d theta will be 2 dt. So it will be 2 raised to 7 integral 0 to pi by 2 sin square t into cos raised to 10 t dt, where we can apply the reduction with m is equal to 2 and n is equal to 10. So it will be 2 raised to 7 into 1 into, start with 1 power less, 10 minus 1 is 9. So 9 into 7 into 5 into 3 into 1 divided by, start with the addition, 2 plus 10 is 12. So it is 12 into 10 into 8 into 6 into 4 into 2, as both are even, multiply by pi by 2. So it is now 5 2s are 10, 3, 2, then this is again 3, this is 4, and then we will try to simplify it. This is 2 square, 2 cube, 2 raised to 3 again, one more 2, 2 raised to 2. So we'll try to write it in the simplified manner. This is 2 raised to 7 is already there. This is 7 into 3, which is 21 pi divided by 2 square. So 2, 3, 6, 7, 8, 9, 10 and 11 divided by 2 raised to 11. And so 2 raised to 7 upon 2 raised to 11 is 2 raised to 4, which is 16. So it will be 21 pi by 16, which is the required right hand side. So that was problem number 2. In case of problem number 3, when the limits are 4 to 6, so LHS is integral 4 to 6 sin raised to 6 pi x into cos raised to 4 2 pi x dx. We will go for a substitution as let pi x is equal to theta. Therefore, pi dx is equal to d theta. Limits x is equal to 4 implies theta equal to 4 pi, and x is equal to 6 implies theta is equal to 6 pi. So substituting these limits, we will get the integral as integral 4 pi to 6 pi sin raised to 6 theta into cos raised to 4 2 theta into dx is nothing but d theta upon pi. So pi can be taken, 1 upon pi can be taken outside, and then we will make a substitution also, because we don't want limits from 4 pi to 6 pi. So it will be sin raised to 6 theta into cos raised to 4 2 theta d theta. To get the limits in our standard format, first of all let us make a substitution that let theta minus 4 pi is equal to t. Therefore d theta is equal to dt. At theta is equal to 4 pi, t will turn out to be 0, and at theta equal to 6 pi, t will become 2 pi. And so it will be equal to 1 upon pi integral 0 to 2 pi sin raised to 6t into cos raised to 4 2t dt will be now the overall effect. Now between 0 to 2 pi, whenever we have even powers of sin or cos, then we can straight away make it 4 times 0 to pi by 2. So this can be written as 4 times 4 upon pi integral 0 to pi by 2 sin raised to 6t into cos raised to 4 2t dt. But this is not sin raised to mx cos raised to nx, this 2t that has to be substituted, and so we will go for writing it as 4 upon pi integral 0 to pi by 2 sin raised to 6t into, it will be cos square t, or you can write it as 1 minus 2 sin square t. I am substituting for cos 2t as 1 minus 2 sin square t bracket raised to 4 dt. Now we are required to expand it, and so it will be equal to 4 upon pi integral 0 to pi by 2 sin raised to 6t into bracket, first term is 1 minus 4 into 2 sin square t. If you know the coefficients of 4th power, the job will be easier, and for that we can use Pascal triangle. It is 1 1 1 to 1 addition of these two, 1 3 3 1, and for power 4 it will be 1 4 6 4 1. That should be the policy. These are the powers These are the coefficients of power 4, power 3, power 2, power 1 and power 0. So it is 14641 that is to be used. And so first coefficient is 1, second coefficient is 4. You will have to keep on reducing power of the first term. So this was 1 raised to 4. This will contain 1 cube. I am not writing that. And power of 2 sin square t will go on increasing. So it is 1, 4, then 6. It will be 2 sin square t bracket square, then minus 4 into 2 sin square t bracket cube, and then it is going to be plus 2 sin square t bracket raised to 4 dt. So let us multiply by sin raised to 6 also inside and write the terms separately. So first term will be sin raised to 6t minus, it will be, second term is 8 into sin raised to 8t. The third term is going to be plus 12, rather it is 6 into 2 square, that is 24. 24 sin raised to 6 and sin raised to 4. So this is going to be sin raised to 10t. Then this is 2 cube is 8. 8 4s are 32. So it will be minus 32. Sin raised to 6 and sin raised to 6, it will be sin raised to 12t. And finally this is going to be 16 2 raised to 4. So it is plus 16. This is sin raised to 8 and sin raised to 6. So it will be sin raised to 14t dt. And use the reduction formula to obtain the result. And so it will be 4 upon pi inside the bracket. First one will be 5 into 3 into 1 divided by 6 into 4 into 2 into pi by 2 minus 8 into, this is 7 into 5 into 3 into 1 divided by 8 into 6 into 4 into 2 into pi by 2. Third one will be 24 into 9 into 7 into 5 into 3 into 1 divided by 10 into 8 into 6 into 4 into 2 into pi by 2 minus 32 into 11 into 9 into 7 into 5 into 3 into 1 divided by, it is 12 into 10 into 8 into 6 into 4 into 2 into pi by 2. And the last one will be plus 16 into 13 into 11 into 9 into 7 into 5 into 3 into 1 divided by 14 into 12 into 10 into 8 into 6 into 4 into 2 into pi by 2. So take the LCM, pi is definitely getting cancelled. Of course, if you want to take something common out of this whole stuff, then probably the first term can be taken outside. It is present in all of them. And so it will be 4 by 5 or 4 by pi into 5 into 3 into 1 divided by 6 into 4 into 2 into pi by 2 taken outside. First term is 1. So this is not there now. So this can be simplified as minus 7. In the second term, this is taken common outside, and so it can be simplified further. It comes out to be 3 into 9 into 7 upon 10. In the third term again this has gone out. So this is into 4. This is 4, 3 is this is 3, 3. So ultimately in the numerator you will be left with minus 11 into 3 into 7 divided by again 10. Everything else has vanished. And for the last term, this is the term which has been taken common. So we can simplify 2. Then it will be 9. So 3 4s are. This is 2, 2. This is 7, 2. and no more simplification is possible. It will be 13 into 11 into 3 divided by, it will be 4 into 10. This is what the simplification that we are looking for. Here this pi cancels, 4 cancels, this is 3, 2. So ultimately outside we have 5 upon 8, within the bracket is 1 minus 7. Now all these terms, they can be added or subtracted. Like from these two, I can take 3 into 7 common. So it will be plus 3 into 7 upon 10. Inside the bracket, it will be 9 minus 11. And the last term remains as it is. Or rather from last term also, 7 is not there, okay. So it will be plus 13 into 11 into 3 divided by 4 into 10. Simplify it and we can obtain the result. That was problem number 3. So rather a lengthy problem, but still we can continue with the solution using the reduction formulae. In problem number 4, where we have got one x term which is present, so the LHS is given to us as integral 0 to pi x sin raised to 5x into cos raised to 4x dx. Now to simplify this, if I treat this as term I, then using the formula I can write it as integral 0 to pi. It will be pi minus x, I am substituting for x pi minus x, sin raised to 5 pi minus x into cos raised to 4 pi minus x dx. This is with the use of the formula that integral 0 to a fx dx can be always written as integral 0 to a f of a minus x dx. This is a valid result. So this will become integral 0 to pi minus x into sin of pi minus x is sin x, so it will be sin raised to 5x, and cos of pi minus x is minus cos x bracket raised to 4 will be again cos raised to 4x. And so this can be splitted up as pi integral 0 to pi sin raised to 5x into cos raised to 4x dx minus integral 0 to pi x into sin raised to 5x into cos raised to 4x dx. But this is nothing but the left hand side, that was I. So this can be written as pi integral 0 to pi sin raised to 5x into cos raised to 4x dx minus I, which can be taken on one side, and you have the result as 2I is equal to pi integral 0 to pi sin raised to 5x cos raised to 4x dx. So I can be calculated, so I will be equal to pi by 2. Now to evaluate this, we want the limits from 0 to pi by 2, and for limits to be 0 to pi by 2, we can either go for a substitution like 2x is equal to t, that could be one policy, but that is not going to help us much. So we will have to take help of some other way of solving the problem, and that is the case when f of pi minus x is equal to fx, that is the symmetry is there. In that case we can straight away make it twice 0 to pi by 2, so it will be integral 0 to pi by 2, because we have just seen that sin raised to 5x into cos raised to 4x is same as sin raised to 5 of pi minus x into cos raised to 4 of pi minus x. Sin of pi minus x is sin x, so this power remains the same, and cos of pi minus x becomes minus cos x, but raised to power 4 it will become cos raised to 4x, and so this result is valid. We can make it twice integral 0 to pi by 2 sin raised to 5x into cos raised to 4x dx, where the reduction can be applied. So it will be pi into, start with 1 power less 4 into 2, start with 1 power less 3 into 1, divided by, start with the addition, that is 9 into 7 into 5 into 3 into 1. And so this 3 cancels. This is 4 into 2, it will be 8 pi divided by, this is 35 into 9, 315, which is RHS. That was problem number 4. Solved effectively. We always think of going for parts. That is not going to help us much. We will have to rather use this very important result, that is integral 0 to a fx dx is equal to integral 0 to a f of a minus x dx, and then resume with the solution. Problem number 5 obviously will be using the same result. Problem number 5 says that it is LHS which is given to us as integral 0 to pi x into cos raised to 6x dx. So using the same formula, it will be integral 0 to pi, it is pi minus x into cos raised to 6 pi minus x dx, which will be integral 0 to pi minus x into cos raised to 6x dx. Cos of pi minus x, we know that cos of pi minus x is minus cos x, but when raised to even power, that particular minus sign will vanish and we get the function as the same one. And so we will again use the same result, and before that we will split the integral, because left hand side is I. So it will be I is equal to pi integral 0 to pi cos raised to 6x dx minus integral 0 to pi x cos raised to 6x dx, which is as good as I. So we can take it on one side, it will be 2i equal to pi integral 0 to pi cos raised to 6x dx. So I will be equal to pi by 2, and this can be written as twice integral 0 to pi by 2 cos raised to 6x dx, with the reason that f of pi minus x comes out to be equal to f of x. You can check that cos raised to 6 of pi minus x will be nothing but minus cos x bracket raised to 6, which is cos raised to 6x. So effectively it becomes twice integral 0 to pi by 2. So it will be pi into, use the result, it is 5 into 3 into 1 divided by 6 into 4 into 2 into pi by 2. And so ultimately it will be 5 pi square divided by, this is 2 into 4, 8 into 2, 16 into 2, 32. That is how we will apply the reduction formula for problem number 5. And then we go to problem number 6, where we cannot see any term like sin or cos. LHS is given to us as integral 0 to 1 x raised to 6 into 1 minus x square dx. Let us go for a substitution that let x is equal to sin t. The substitution will be always suggested by the terms in the problem. Whenever it is difference of squares, the substitution should be sin or cos. So we make a substitution, x is equal to sin t, therefore dx will be equal to cos t dt. Limits x equal to 0 will imply that sin t is equal to 0 will imply t is equal to 0, and x is equal to 1 will imply sin t is equal to 1, that is t is equal to pi by 2. So this becomes integral 0 to pi by 2 sin t bracket raised to 6 into under root of 1 minus sin square t into cos t dt. And so it comes out to be integral 0 to pi by 2 sine raised to 6t. This is 1 minus sine square is cos square, root of it is cos, cos into cos is cos square t dt. Apply reduction, it is 5 into 3 into 1 divided by, start with sum of the powers, so it is 8 into 6 into 4 into 2 into pi by 2 as both are even. So it is 5 pi upon, this is 16 into 4, 64, 128, 256, and that was the required right hand side.